In this section, we will see how to create and use arrays in Python. So what do you mean by array? Array is actually a collection of data items which are of same kind, or we say it is a homogeneous collection of data items. But in the case of list and tuples, the data items are heterogeneous. But in array, it is actually a homogeneous collection of data items. So the array in Python, it is supported by the NumPy package. So NumPy stands for numerical Python. We already know what is a package. We have already seen math module. So if you want to use a math module or use a function math module, what we do is we first import math, then we will call that function as math dot. If you want to get the value of pi, you should call math dot pi. Similarly, if you want to create an array and work with an array, you should first import the NumPy package. Okay, so first step is to import the NumPy package, because array, all the functions of array are supported by this NumPy package. Where will we use this array? The arrays are mainly used for advanced computing, so like linear algebra, or you have to find out some Fourier transforms or some random simulations, etc. You will be using this array. So we will see one example. So as I said, if you want to create an array, the first step is to import NumPy package. Okay, so import NumPy. So I import this NumPy as NP. So NP is just a short form. So whenever you are using math module, when you call a function in math module, you will say math dot. Okay. Similarly, when we are using NumPy, if you want to call a function in NumPy, instead of using NumPy dot, you can simply call it as NP dot. So we import the NumPy as NP. NP is just the short form. So whenever you call a function in NumPy, you can just call it as NP dot. So the first step is to import the NumPy. Then consider a variable here. Then I am going to create an array. So to create an array, I use an NumPy library. That is a NumPy package. That is NP dot. And the syntax is NP dot array. You can see a list of functions which are available in the NumPy are listed here. So to create a array, we will use the command np dot array of. Okay. Then the array should be enclosed within a square bracket. So np dot array of within a square bracket. You have to specify the elements. If you have a single dimension, you can just write down the elements by separating each element by comma. So this is a single dimensional array or a one dimensional array. So when you print array, it is a one dimensional array. If you want to create a multi-dimensional array or two dimensional array or some matrices, you can use the same command. I use another variable mat and I use the same command np dot array of, and the element should be enclosed in square bracket. And if you have two dimensions, the first row should be enclosed in a square bracket. So I have the first row with elements 1, 2, 3. Each of the elements should be separated by comma, and the first row I have enclosed in a square bracket. Then the second row is again enclosed in another square bracket. The second row is 4, 5, 6. It is enclosed in another square bracket, and each row should be separated by comma. So this is the syntax. So np dot array of, the whole element should be enclosed in square bracket, similar to that of a one dimensional, and here you have two dimensional. So the first row should be enclosed in a square bracket, second row enclosed in another square bracket, and each of the rows are separated by comma. So this is the syntax. So when you just print the mat variable, you can see it is a two-dimensional array with first row as 1, 2, 3 and second row as 4, 5, 6. Now You can check the dimension, the first variable bar AR. To check the dimension, you can simply use n dot ndim, n dimension, AR dot ndim. So the first one is a one dimensional array, so you will get the dimension as 1. When you check the dimension of MAT, it is a two dimensional array, so the dimension is 2. If you want to get the exact shape of this matrix, you can use MAT dot shape. It should give the exact shape. That is, here you can see this is a matrix and it is having 2 rows and it is having 3 columns. So when you use the command dot shape, it will give 2, 3. That is 2 rows and 3 columns. Then how to access the elements in an array? So if you want to access the element 3, you can use the indexing. That is 1 corresponds to 0, 2 corresponds to 1 and 3 corresponds to 2. So you can use the index AR2. So AR2 is actually 3. Is it? The 0, 1, 2. Second index is 3 and it is actually NNP.in64. So the value is 3. Similarly, if you just type MAT of 0, index usually starts from 0. Okay, so MAT of 0, it will give the 0th row. So see, MAT of 0 gives 1, 2, 3, that is the 0th row. If you give MAT of 1, if you give the index as 1, it will give the first row. If you want to get the element 2 from this matrix MAT, it is element 2 is actually the 0th row, first column. So you can give MAT of subscript 0th row, first column. Okay, so you can just use comma. Okay, so 0th row, first column is element 2. You will get 2. Or you can simply use 2 square bracket. The first square bracket represents a row, that is 0th column, and second square bracket represents a column, that is a first column. You can either separate this row and column by comma, or you can use 2 square brackets in order to retrieve or access the elements in an array. Similarly, you can use slicing. You can use MAT of, if you want to get the consider you want to get the last row. Usually you write it as -1. Is it? -1 represents the last row. Then if you give last row 2, what will be the value? If you just check this value, -1, 2. -1 represents the last row and 2 represents the second column, 0, 1, 2. So what will be the value? The value will be 6. Now coming to slicing, you can retrieve an element by using the slicing operation. That is, if you, this is your array AR, if you want to retrieve 2, 3 and 4, you can give the index. Index of 2 is 1. So starting from 2, put colon. Similar to that of slicing that you have seen in list, etc. So you can have 1, then 2, 3. If you want to get the index up to 3, you have to give 4 as a stop index. So 1 to AR of 1 to 4. That will gives you the index 1, 2 and 3. So you will be getting 2, 3 and 4. So this is how you do slicing in array. Then in order to traverse an array, you can use the for loop. For I in AR. Okay, if you print I, what happens is it will traverse through each of the elements in the array. Okay, so it will be, first you will get 1, then 2, then 3, 4, 5, 6. Okay, similarly you have MAT is given by this. If you use a for loop to traverse through that matrix, for I in MAT, if you have the command print of I, see, you will get I in MAT, that is first I will corresponds to the first row. Okay, so you have a two-dimensional matrix. So what happens is when I equal to 1, I equal to 0, you will be getting the first row. Then for the second I, you will be getting the second row. So this is how you traverse through a matrix. Then there is a command reshape. So matrix is this. If you use the command mat dot reshape, and actually the matrix is 2 rows 3 columns. If you give 3 rows and 2 columns, what happens is, you can see it is reshaped to 3 rows, total 3 rows, and there are 2 columns. And see, if you just give mat dot reshape 5 comma 2, what happens? It will show an error, that is cannot reshape array of size 6, because here you have total 6 elements. So if I give 3 into 2 6, it can be easily arranged as a 3 by 2 matrix. But if you give 5 into 2, there should be total of 10 elements, so it should shows an error. So these are the reshape operation used in array. Then there are some matrix operations also. If you have two matrices x and y, then you can use add command dot add, that is np dot add xy. It will give the addition of two matrices. Np dot subtract xy will gives you the difference between the matrices. Then np dot matrix multiplication, mul will give the matrix multiplication, and to get the transpose you can use x dot p. It will give a transpose of the matrix. So these are the different matrix operations supported in NumPy. So just go through each of these cases, give some examples for x and y, create two matrices, and try to implement each of these functions: add, subtract, matrix multiplication, and transpose. Okay, thank you.